Processing is nothing but what? Conversion of the data into information. System software, it is nothing but it is a set of instructions or a set of program which are going to controls and coordinate working of each component of a computer system. So this input unit is a combination of one or more input devices. I can take keyboard, mouse, scanner as an example for input unit. Hello everybody, welcome to the first session on your first PUC's Computer Science first chapter, that is Overview of a Computer. Myself Rohini TS, lecturer in Computer Science, Vidhyaashram Pre-University College, Mysuru. So before getting into the deep discussion regarding this chapter, let me have a blueprint. So this blueprint will going to depict us what is the marks distribution of this chapter. If you look at this tabular column, you are going to get total 8 marks from this chapter. If you read all the topics of this chapter, you are going to get 8 marks. Then how the marks will be distributed? So you are going to get 1 mark 1 question, and then 2 mark 1 question, and 5 mark 1 question. That is totally you are going to get 8 marks from this chapter. Then what are the topics that I am going to cover in today's session that you can list it out here? So that is definition or a introduction of a computer. So what do you mean by computer and what is its definition? And then I am going to have a look regarding this characteristics of a computer, how the computers are characterized and all. So that is regarding characteristics of a computer. Then I am going to discuss about data and information along with hardware and software. So these 4 are the basic components of a computer system: data, information, software and hardware. Then I am going to discuss regarding the functional components of a computer system. Very, very important topic. So now let me get into the today's session, that is definition of a computer. So we are all familiar with the word called computer. So nowadays we are all going to use the computer system in our daily life, right? So and we cannot imagine our life without computers. That means that much we have dependent on the computer system or any other electrical media or electronic machines or a media. Then what is this computer? So if you see the definition, computer is an electronic machine. So computer is an electronic machine, and what it will going to do? It can store, it can recall and it can process the data. So what it can do? It is some electronic machine. It can store, it can recall and it can process the data. So I am going to discuss what do you mean by storing, what is process or what is data and all. So as of now, you just remember the computer is an electronic machine. It can store, it can recall and it can process the data. So I am going to give some tasks to the computer system. At that time, the computer will going to process the data and it will going to give me the resultant. So to make our life easy and to reduce the complexity of any of the problem solving methodology, we are going to use the computer system. So then how computer will going to work? How does the computer work? So here I have taken a real-time scenario to make you understand that how the computer will going to work. So for this, you have to follow IPO format. Then what is this IPO? It has to take the input from the user, then it has to process the data and it must give me the output as a result. So now let me prepare a tea for you. So what you are saying? You are going to prepare tea for us. So that means I am depicting that how the computer will going to work. So what are the ingredients that I require in order to prepare a tea or any of the coffee like that? So then I require water and tea powder is required. Then I require milk and sugar. So then what I can call all these ingredients as? I can call this as a input. So this is nothing but input. So I am giving the input to the computer. So what I am giving? I am giving the input to the computer. It has to process. This is the necessity of processing. Out of that processing, I am going to get the resultant as a output. So then what is the processing in order to prepare a tea? It has to be boiled. So I am going to mix all the ingredients, then it will start boiling. So that boiling is a process that is called as processing. Then what will be the resultant or output? That is tea. I am going to get a tea. So I can call this as a output. Okay, so now just recall and imagine that I'm going to give some data to the computer system based on my requirement. It will going to process and it will produce the output. So this is how computer will going to work. Then what are the characteristics of a computer? How the computers are characterized? If I consider any person, each person has a unique character. So by that character, I can say that yes, she is like that and he is like that. In the same way, if I consider the characteristics of a computer, computers are characterized into some of these things. So what are the characteristics? So you can see here, that is speed. Computer has speed and it will going to produce the data in a speed manner, and it has the ability to store, that is storage, and it will going to produce the data accurately, that is accuracy, and elegance, versatility is there. Computer has the flexibility and it has cost effectiveness. So then how to remember all these things? I have a code for you in order to remember the characteristics of a computer. So that is SMSAVACD. So how to remember characteristics of a computer? SMSAVACD. That S is nothing but storage, memory, and speed, automation, then versatility, accuracy is there, and cost effectiveness is there, and delegate. So these are the characteristics of a computer. So these characteristics of a computers are important for 5 marks question. So what are the characteristics? It can store, it can memorize, and it has a speed, it can be work automatically, and then it is versatile in nature and it will going to produce the data accurately, and it is cost effectiveness, and then delegance. So we'll see the character one by one. So that is speed. Listen the word speed, then what comes to in your mind? So you are going to recall something. In the same way, computer also will going to perform the task in a fast manner. So that is, the computer work very fast. How fast it is? Then that will be measured in terms of MIPS and BIPS. That is, computer will going to perform, or computer will going to process the data million instruction per second. If I say the second, so then also it will require 1 or 2 seconds. So in that particular second only, the computer has the ability to process millions of instruction, even billions of instruction. So that is nothing but computer will going to produce the result, or it will going to process the data in that manner. So the speed of a computer is measured in terms of MIPS or a BIPS, that is million instruction per second, then billion instruction per second. And this abbreviation is also important for 1 mark question. Expand MIPS and BIPS. So this is regarding speed of a computer. Then what is the next characteristics? That is storage. So if I am working with computer, in the sense what? It has to store the data. So without storing, that will be waste of time and effort. So in order to store the data and information in the computer system, then there must be some storage media. So what is the next character then? That is storage. Computer can store a large volume of data. If I consider a human brain, then it will going to depict that which are the necessary things I need to remember. So it will going to hold only the important data and information in our mind, and which it may feel not necessary to remember, then it will going to forget and it will send to the back of a brain. So in the same way, this computer will going to store the data and information which is necessary and which is required for fast processing, which is required instantly or immediately. So that is storage. The computer has the ability to store large amount or a bulk amount of data. So that is, computer can store large volume of data and information. So it can store data and information which is large in amount, or its size is more. So it will going to store. Then how the computer's storage capacity will be measured? It will be measured in the terms of bytes. In the terms of bytes. So then what can I say byte as? So you all know that computer understands only 0 and 1. So I can call that 0 and 1 as a bit. If it is a collection of 8 bits, then that is nothing but byte. So computer has a ability to store the large volume of data. Then in order to find the storage capacity of that computer, I can have the measurement term, that is byte. So byte is nothing but it is a collection of 8 bits. So 0 and 1s are the bits. So if it is a sequence of 8 bits, then I can call that as a byte. So that is the thing you have to remember. Then what is the next characteristics of a computer? That is accuracy. So the main thing that we are all fond of computer is its accuracy. So if I give 2 plus 2, then it has to give me 4. The computer is always correct. If the software and any of the program is fail or error, then only I may get the error result or a error output. But when it compares to the computer, it is always exact and it will produce the result and information without any mistakes. So that is the main advantage of using computer. If I consider accuracy, so the computer generated results are exact. So it is always exact. If I ask the computer to add 2 plus 2 in the morning, then it will going to give me the result as a 4. If I ask the same question 2 plus 2 at the night, then also it will going to give me the accurate result. So that computer will going to give the resultant or output is always exact and there will be no mistakes. So there will be no mistake, that is without any mistakes, with a high rate of consistency. So I can give the same input thousands of times, but it won't give me the error data or error result. It will always going to give the exact result and a error-free result. So that is one of the characteristics of a computer, that is regarding accuracy. Then what is the next characteristics of a computer? That is diligence. So if I give some homework or assignment to you in order to write a same question 100 times, so then what you are going to do? You are going to write 10 times in a faster manner. After that, another 90 times what you are going to feel? So you may feel like tired and you may feel lazy. But if I give the same task to the computer system, at any point of time, does it feel any tired or a lazy? Will it going to lose its concentration? No. So that is nothing but what? Diligence. So computer does not suffer from any limitations like tiredness. So computer won't get tired. If I give the any task to computer perform from 24/7, it will going to perform. It won't feel any tired and it won't lose its concentration. That is the biggest advantage of computer. That is diligence. It can work for hours without making any of the errors. So it will going to produce the same result. It will going to produce the same process at any time and all the time. So computer won't feel tired or it won't feel lazy or it won't lose its concentration. That is nothing but what? Diligence. So then what is the next thing? That is versatility. So computer is versatile in nature. How can I say computer is versatile in nature? It will going to perform any kind of task, whether it is a simple task or a complex task. So for all the things, computer will be master. So that computers are capable of performing any task. So if I give 2 plus 2, then also it will going to add. If I give any 4 digits multiplication value, then also it will going to perform. Even if it is related to scientific, then also computer will going to perform. So that it is versatile in nature. That means it will going to perform any kind of task. It has the ability to perform any kind of task. So it is capable of performing any task. That is nothing but multi-processing. More than one type of process it will going to perform. That is multi-processing. So that makes the computer versatile in nature. So as I told earlier, if I give any simple calculation, then computer is also versatile in nature. If I give any complex related work like scientific research and all, then also it will be master. That is what they mean. Computers can be adapted to any of the field easily. So it is used for scientific purpose and it is used to play the games. So if I give any task to the computer system, at that time it will going to get adapted to the particular type of task. That made the computer system versatile in nature. That is versatility. Then what is the next characteristic? That is flexibility. So flexibility in the sense what? Computer can do any kind of task. So here flexibility would be involved the number of things the computer can do. That means we can do with a computer. I can use the computer in order to play the games. I can use the computer for scientific research. I can use the computer for research processing or any of the small task, right? So flexibility in the sense computer can do any kind of task. So it is same like versatility, and it is automated in nature. If I once started the process, then computer will going to perform its operation. So without any tired or without any laziness. So that is made the computer system flexible in nature. Then what is this cost effectiveness? Let me take one example. Now just imagine, now we don't have any computers or any of the electronic machine. I have a bank and I have to enter the transaction. The whole day's transaction I have to enter. At that time, what I'm supposed to do? I must have one ledger. I have to enter all the transaction which takes place in a particular day. But when we have a computers, so instead of writing everything in the papers, we can store or we can have the data, copy of the data and information in the computer software. So that made our life easy. So cost effectiveness in the sense, by making use of the computers and its software and everything, I can reduce the amount of paperwork, and it also reduces the human effort. So instead of writing, I can easily type the data into the computer system and no paperwork is required. It will going to reduce the human effort. That is the main advantage of this computer. So computers are not so costly. If you go with the basic configuration, it is reliable in nature. So that what computers are cost effective. So I can reduce the human effort along with the usage of this paperwork. That is regarding this cost effectiveness of a computer's characteristics. So it's all about the characteristics of a computer. Then what are the components of a computer we have? What are the basic units that we have in a computer? When it comes here, the components of a computer system, again it will be categorized into 4 parts, that is hardware, software, data and information, and then user or a users. Okay, so let me have a look regarding this hardware. So then what is this hardware? Hardware is nothing but it is a physical component of a computer system. You all are familiar with a computer. If you look into that computer, you may see that monitor, keyboard, mouse, everything is there. Can I see that? Yes. Can I touch that? Yes. So even I can feel that yes, it is a keyboard, yes, it is a mouse, like that. Hardware is nothing but what then? It is a physical component of a computer system. That is hardware. I can call that physical component as a hardware, and that hardware components can be seen, touch and feel. I can see that hardware components, I can feel that hardware components, and I can touch that hardware components. Then what are the examples for these hardware components then? So what are the components that you are able to touch on the computer system? We can touch mouse, keyboard, scanner, printer, everything. So this component may either resist inside the computer or even outside the computer. So based on that, I can categorize this hardware, whether it is located inside the computer system or outside the computer system. If I consider RAM and all, so that will reside inside the computer, but I can feel and I can touch that. So that is regarding this hardware, and examples are keyboard, mouse, monitor, printer, RAM and CPU. It is related to hardware. Then what is software? I know how to work with a computer system, but computer know how to work? No. So without any program or a software, computer is a dumb machine. So I have to give some instruction. Based on that some instruction, computer will going to work, isn't it? So in order to give all the instruction, I require this software. Then what is this software? That is a set or a collection of a program. That is known as a software. I know I have a hardware and I want to make that hardware work. Then how to make that hardware work? I'm supposed to give some instruction to that one. I'm supposed to give some instructions or a program to that one in order to make the hardware work. So by making use of this software, it will going to tell the hardware what to do and how to do. That is regarding software. So software is a set of instructions or a collection of program. So it is nothing but software. It will going to tell the computer or a computer hardware in order to perform a particular task. And one thing, we cannot touch and feel the software. Okay, we cannot touch and feel the software. Then what are the example of this software? If we consider the example here, I can have operating system. Without operating system, computer is a dumb machine. So without that, it cannot do anything, right? That is operating system. Can we see the operating system? No. Can we feel and touch? No. So that is related to software. And I can also have this Paint and Office package that includes MS Word, MS Excel, MS Access, everything. We can work with that, but we cannot touch and feel. So that is regarding this software. And what are the types of software we have? We have two types of software, that is system software and application software. When it comes to the system software, so that is system software, it is nothing but it is a set of instructions or a set of program which are going to controls and coordinate working of each component of a computer system. It will going to schedule the programs, it will going to have a control over all the programming. So that is nothing but system program or a system software. I can take an operating system as an example for this type of software. Then what about this application software? When it comes to the application software, these type of softwares are built in order to perform a particular task. So that kind of softwares are nothing but application software. I can take what Office package as an example and Paint as an example for this application software. So I am going to use the tool Paint in order to perform a painting operation, so that I can use that software for a particular type of task. That is nothing but application software. So then what is the next component? That is data, information, and then user. Then what is this data? So data is nothing but it is a raw facts or a raw element that needs to be processed. And what data could be? It could be anything. It can be either image, text, numbers, video, audio, anything. So data can be anything. So if you see here, data is nothing but it is a collection of unprocessed item. What is this? It is an unprocessed item that needs to be processed in order to get the information. So data are unprocessed facts or unprocessed items. So what data can be? It can be text, number, any image or a video. Okay, so I have an image, I need to upload that into social media. At that time, what I am going to do? I am going to snap that image and I am going to apply some filters. So without that filters, the data or image is a data, that is raw fact. When I am applying that filter, that is processing. So after that processing, I am going to get some image. So that is information. So when you consider this information, it comprises of, it is a processed organized data. So it is a processed and organized data which is presented in a meaningful context. It is presented in a meaningful context. There must be some meaning to the information. There must be some meaning to the processed data. So let me take one example here. Prashant 12. So what do you mean by this? Prashant 12. So do you get any idea regarding this? Prashant 12. So then what does this 12 means? Whether it is its age or its door number. What is this? So this is nothing but data. It is in the unprocessed manner. It is a raw fact. Then I am going to write it like name is equal to Prashant, and then I am going to give its age as 12. So which has more meaning? Whether this one or this one? It has more meaning. So I can call this as a information. So this is nothing but data. So data are the raw fact that needs to be processed in order to get the meaningful context. But when it comes to the information, informations are a processed data. So here I have a data which is in the processed form and well organized form. So that I can call this as a information that is used to take me the further decisions or an actions. So that is information. Then what is user and who is user? The person, one who is using the computer, is a user. If you are working with your computer system, then you will be the user. If you are playing game with your friends in the same computer system, I can call you both as a users. So this is regarding basic component of a computer system or a basic terminology. So what and all you have to remember. Here I have a data, information, user, and hardware, software, and types of software. Getting? So these are all the components of a computer system. What is the functional units of a computer system? So at that time you have to remember one thing. First, I am supposed to give the input to the computer system. So I have to give some data and programs to the computer system as an input. So computer will going to accept the data and programs as a input, right? So once it accepts the data and program as an input, what is the next step? It has to store the data. It has to store that data for the further processing. So it will going to store the data and program and retrieve as and when it is required. So it will going to retrieve the data and program when it is required. So once I am done with storage, and after that I have to process that data. So as I told, processing is nothing but what? Conversion of the data into information. So it will going to process the data as per the instruction which is given by the program. I have a set of instruction. In that instruction, I am going to say that it has to perform the operation like this. So based on that instruction, this computer will going to process the data. Once it is done with its processing, it has to produce a result, that is output. So communicate the information as a output. So it has to follow IPO format, input, processing, and output. Based on our requirement, it has to process the data. So then what is the block diagram of a computer? So that is nothing but functional components or a functional units of a computer system. And this is also important for 5-mark question. So what are the functional components of a computer system? Explain with a block diagram. So computer has 4 units. Input unit and then CPU. Under the CPU again it is categorized into control unit and then arithmetic and logic unit, then registers. So the third component or a unit is memory unit, then we have output unit. So now we'll see one by one along with the diagram. So here you can see the block diagram of a computer. So what and all I have? So I have an input unit. I have an input unit and then I require this CPU, that is central processing unit, and I have a storage unit, that is memory unit. So this is the first element or a component, this is the second one, and this is the third one. At last I am going to get the result by making use of this output unit. If you look into this block diagram of a computer system, here I have a input unit. So this input unit is a combination of one or more input devices. I can take keyboard, mouse, scanner as an example for input unit. What is the usage of this input unit? It will going to accept the data and program from the user. It will connect the external world to the computer system. So if you see here, when it comes to the input unit, computers needs to receive the data and instruction in order to solve a problem. If I want to solve a problem by making use of the computer, at that time the user has to give the data and information. So that data and program are taken by the care of input unit. So this input unit will going to take, or it will going to accept the data and information which is given by the user by making use of the input devices. Then this input unit links the external world. Very important. What it is doing? It is connecting the external world to the computer system. So user will be in the external world. So I am going to fed some data and information to the computer system. By this input unit, it is creating a bridge between the external world along with the computer system. It will going to accept the data and program which is given by the user from the environment, that is outside of the computer environment, then that will be links to the computer. So you all know that computer understands only zeros and ones. So when I am giving the data and information as any text data and information, that needs to be converted to the machine understandable form, that is zeros and ones. But when I am getting the output, that must be in the human understandable form. If the output is like zeros and ones, can I understand? No. So when I am giving the input, input, I am going to give the input in the human understandable form by making use of the input unit. But when it receives the data and programs, at the time it will going to convert that data into machine understandable form. So by taking that data and information, computer will going to process. Then that processing will be takes place in the central processing unit, that is CPU. How the human brain is important for the human, in the same way the computer CPU is also important. So I can call the CPU as a brain or a heart of a computer system, that is central processing unit. So what is the usage or a function of the CPU then? It will going to interpret the instruction in the program and execute them one by one. So I am going to give some data and information to the computer by making use of the input unit. When it reaches to the computer CPU, at that time it will going to interpret or it will going to process that data as a information with regarding of this programming. So function of the CPU is to interpret the instruction in the program and then it will execute them one by one. Then how the CPU is categorized? So again the CPU consists of 3 subunits or 3 major units, that is control unit, arithmetic and logic unit, then register. When it comes to the control unit, as the name indicates, control in the sense what? It will going to controls and coordinate working of all the components of a computer system. So that is, it controls and directs the transfer of program instruction and data between the various units. So we all know that it has 4 units, right? Input, memory and CPU, then output. So this control unit, particularly this control unit, will going to hold or it will going to have a control over the data transparency between the various components of a computer system. So when it comes to the arithmetic and logic unit, so as the name indicates, arithmetic and logic unit. So when it comes to the arithmetic, what are the arithmetic operations that we can perform? Addition, subtraction, multiplication, division. When it comes to the logic, and, or, and, not. So in arithmetic and logic unit, main execution of a program will going to takes place, that is calculation will be takes place in the component of arithmetic and logic unit, that is ALU. So arithmetic operations and logical unit perform the arithmetic and logical operations and controls the speed of these operations. So that is, I can compute the speed of a computer, right? So that is million instruction per second. So this arithmetic and logic unit will going to control that speed, whether it must be million instruction per second or a billion instruction per second or several instruction per second. So that will be takes place under the scope of this arithmetic and logic unit. So then what about these registers? I have some data and information that needs to be processed and that must be sent to the output. So if I require to store the data in a memory, at that time I must have a buffer. So that is temporary storage is required. So these registers are the temporary storage unit which is mainly used to store the instruction and intermediate data. So now I am not conclude the output, but I am still in the processing. So when it processing the data and information, that must be stored somewhere before it reaches to the output unit or to the memory unit. At that time, that kind of data will be stored in the registers. So this is regarding CPU. So CPU is going to work or it will interpret the instruction in the program and it will going to execute one by one. And it has 3 components: control unit, arithmetic logic unit, and then it has registers. So this is regarding CPU. So then which is the next component? That is memory unit. So why the memory unit is required? So I have data and programs that is in the processing, but that is not the actual result. So in between that, I have to store that data in memory. So memory is a storage space where I can store the data and information. So the data and instruction which is required for processing have to be stored in the memory unit. So before it will going to work or before it will going to depict as a actual program or actual resultant. So when I'm processing the data and instruction, at that time the data and program must be stored somewhere for the immediate processing. So that will be stored in the memory unit. So this memory unit will going to give me the storage space in order to store that data and program. That is memory. Then what are the types of memory we have? We have two types of memory, that is primary memory and secondary memory. So when it comes to the primary memory, that is also known as main memory. When it comes to the secondary memory, that is also known as auxiliary memory. So this primary memory, for example, if I want to store the data and information temporarily, at that time I require this main memory, and which is required for the instant processing. At that time data and program will be stored in this main memory. Example is RAM. But when I want to store the data and information in a permanent manner, at that time I have to go with this secondary memory, that is auxiliary memory. Then which is the example for this one? Pen drive, CD and all the secondary storage devices I can take as an example for this secondary memory. So here I have a note. What do you mean by peripheral devices? Already we learned that what is input unit, what is output unit and what is secondary storage devices. So all these together I can call this as a peripheral devices. So input unit, output unit along with a memory I can call together as a peripheral devices. So now let me get back to this image now. So that is a block diagram. Here I have an input unit. So with the help of this input unit or input device, I am going to give the data to the computer system. I am going to give the data to the computer system. When it receives, it will going to convert the data and program into machine understandable form. So for the calculation, it will be reaches to the CPU, that is central processing unit. So it will going to perform the action based on the user requirement. If I have any arithmetic and logical operation, then it will reach us to this phase. So it will reach us to this arithmetic and logic phase, and this control unit will going to controls the data transparency between the various components of a computer system, and this register will going to hold the data temporarily, which is required for the instant processing. So here you have to consider one thing. So whether it is a data flow or a control flow, dotted lines depicts that control flow and that arrow depicts the data flow, how the data is flowing between the various components of a computer system. Now I have given some data and the processing has been takes place in the CPU. So once it is done with the CPU, and I have to store that data, whether it must be either primary memory or a secondary memory based on the requirement. Whether I want the data and programs to be in a temporary, then main memory I am going to use, or a primary storage. Whether I want to store the data and information in the permanent manner, then I have to go with secondary storage. So once I am done with all these things, what I am supposed to do? I have to give the result as a output. So that output will be displayed on the screen, or that will be in the printed form. So that is nothing but output unit. So we are going to get the information. So first I am going to give the data, it will process and it will store, then it will going to give me the information as a result. And this is important for 5-mark question. If you see the output unit, so output unit is why we are going to use this output unit. It is mainly a combination or a collection of one or more output devices. So it is mainly used to print or display the result which are stored in the memory unit. So I have a data and that will be processed, that will be stored in the memory unit. I am going to display the data in the output unit. So what is the, it is just like a reverse of the input unit. So in input unit, it will convert or it will connect an external environment to the computer system. But when it comes to the output, it will going to connect a computer system to the external world. So that is output unit will link the computer to the outside world or a external world. Then what is the example? That is monitor and printer are the more commonly used output unit or output devices. So it's all about today's session. In the next session, I am going to discuss with evolution of a computer, how the computer evolved from abacus to next computer system. I am going to discuss in the next session. So it's all about today's session. I'm going to meet you in the next session with evolution of a computer system. Until that, keep learning, keep on growing. Thank you very much.